So one of the most important things to start recognizing is that from this point on in the semester, this course really becomes a course in critical reading more than anything, okay? So for most of you, the biggest challenge is going to be reading a problem and recognizing what they actually want you to do, what they're asking for. As we move forward, it'll be things like confidence intervals and hypothesis tests, what distributions to use, right? But let's start getting used to that now, right? So as we read a problem, right, the biggest thing on the midterm, different from the homework, is you don't know what section you're working in, right, when you're on the test. So we need to recognize when we read a problem. Here's a standard deck contains 52 cards. One card is selected. Compute the probability of randomly selecting a 6 or a jack. Okay, so this is just a basic probability problem, right? So just things we need to recognize. Or, we associate or with addition in probability, right? So that means I'm going to calculate the probability of finding a 6. I'm going to calculate the probability of finding a jack. I'm going to add them. Then you jump to this one. Again, not one of our most complicated probability questions yet, but it's a little different. You have a shipment of 12 televisions. Some work, some don't, right? So then the first question is the probability that both televisions work, right? As we read that, we want to understand the language. That both means this is going to be a series of events, right? You're selecting 2 televisions, and the probability that both televisions work. Well, that means I'm selecting one that works and then another that works, right? And that word "and" implies we're going to multiply, right? So it's a series of events, and we're going to multiply probabilities. Then I jump to a problem like this, right? And this is also a probability problem, okay? Now there's a little bit of a tip-off in part A, but the place that we want to get to is where if they didn't have part A there, we read this and say, oh, according to an airline, flights on a certain route are on time 80% of the time. They're actually already giving us a probability. So it's a probability question that's already giving us a probability. It doesn't make sense for that to be anything but a binomial experiment, because binomial experiments have a fixed number of trials where the probability of success on a given trial stays the same, right? So if it's a probability question that's establishing a probability for you right off the bat, then likely it's a binomial problem, right? Because that's the context in which it makes sense. And then the rest of the things should make sense too. There should be a fixed number of Bernoulli trials, all that sort of stuff, right? Those are the things you need to learn what to look for, right, as you read these problems. Then you encounter a problem like this, and the first line says the number of chocolate chips in an 18-ounce bag of chocolate chip cookies is approximately normally distributed. Boom, there's the magic words, right? You're going to use the normal distribution to solve this. So the first thing I'm thinking is, okay, I need to understand what the mean and the standard deviation of this approximately normal distribution is. Oh, there we go. Mean 1252 and a standard deviation of 129. Now I have everything I need, right, to be able to go to StatCrunch and use that nice graphical interface to calculate some of these. So let's do the first one. Between 1100 and 1400. So once I'm in StatCrunch, I'm going Stat Calculators. I want the normal distribution, right? And I've got this beautiful graphical interface that makes these sorts of problems easy. And problem A was a between, right? So I'm going to pull up the between calculator, and this gives me the between window, right? So once I put the mean and the standard deviation in, I said I'm working with a normal distribution that have these parameters, right? Then I'd like to know the probability of randomly selecting a bag that has between 1100 and 1400 chips in it. So I have a compute, and boom, there I can see right off the bat, is this the window I was looking for? And it is, right? Between 1100 and 1400. This looks great. It gives me the probability. And this is more accurate than getting z-scores and using your charts, guys, because this is doing calculus on a continuous curve. Your table is discrete values. So this is really how we want to be tackling those problems. But the way that we start is by recognizing, right, the language in the problem and understanding, oh, I'm just working with a normal distribution that has these parameters, right? And it's a probability, and probabilities mean area under the curve. That's what we want to start associating as we move forward. Probabilities are areas under a continuous probability curve. Another bit of language I want to point out. I mentioned early in the semester that the terminology is very important, right? When they say percentile, that's area to the left, right? Percentile means, if I say the 80th percentile, that means the point at which 80% of the distribution falls at that point or below, right? So percentile means something very specific. Keep that in mind as we move forward. So those are a few of the major keys as we move forward, right? Don't try to do everything just as mimicking a procedure. Understand the language. Understand what the language is asking you to do, what it's giving you in terms of givens, right? In terms of the parameters of a distribution, if you're working with a continuous distribution, whether you're working with a binomial problem, right? These are the things we need to be able to pick out. When you're working in a section in your homework, it's obvious, oh, they're having me practice this skill because this is what we learned in this section. But we need to piece it together and understand that the language, right? The language is going to tell us what we need to do. It's going to give us a procedure that we need to perform. It's going to ask for a likelihood that I need to be able to give. Okay, so this course is a course in critical reading. Please treat it that way.